information. Can you put this presentation into sliding mode?
Yes, sir. Yes, sir.
Please put it in the presentation mode.
Yeah.
Thanks a lot.
Right, sir.
Yeah. Please go to the first slide.
Yes, sir.
Okay, thank you.
You're welcome, sir.
So I welcome all the participants in today's webinar. So let me give a brief introduction about myself. So my name is Dr. Shabir. I'm working as a senior scientist, soil science at Central Institute of Temperate Horticulture, SIT, Srinagar. Today I will be talking about vermicomposting, a pathway to sustainable agriculture and enhanced livelihoods. Please go to the second slide. Continue. Now, when we talk about health, and the basic thing is why do what we talk about vermicomposting and why vermicomposting right now? In recent years, you might have heard about natural farming, organic farming. So a lot of sustainable agriculture. A lot of these terms are coming into it has become a buzzword now. So why do we care about these terms and why we need to focus on sustainable agriculture? Why do we need to focus on organic or natural farming? So over the years, we have seen that there has been a sharp increase in the disease like Alzheimer's disease, dementia, especially in the women, or Parkinson's disease, like in case of men, then autism. This has happened, the surge of these diseases has increased since the Green Revolution. So Green Revolution, apart from increasing the crop production, we have seen the disadvantages in terms of disease occurrence among the human beings, not only the human beings, but in animals as well. So the sustainability is at stake. The human sustainability and the existence is at stake. If we continue to use these chemical fertilizers, pesticides, the way we have been using, it's going to hurt us badly. So there has to be a system that could, handle these situations very promptly and properly. So go back to next slide. Go to next slide, please. Next slide, please. And when we see the soil health status in India, these are some key statistics. The nitrogen deficiency in Indian soils is around, 89% of the Indian soils are deficient in nitrogen. Like in phosphorus, 80% of the soils. And in case of potassium, our Indian soils are almost 50% deficit, the cultivated lands. Similarly, we have a zinc deficiency in about 48% of the Indian agricultural soils. Our organic carbon is decreasing rapidly, and right now it is less than 0.5%. And on the other hand, when we see the soil testing coverage, only 30% of the farmers use soil testing services. And when we talk about the soil erosion, nearly 147 million hectares are affected by the soil erosion in India. And when we see and compare it with the chemical fertilizer use, India uses around 27 million tons per year, which is a huge number. And we also, when we talk about the crop residue burning, almost 23 million tons of the residue burned is burned annually in North India. So there is a huge gap in terms of, using the sustainable practices to cater the deficiency of the nutrients in the soil. So next slide. And when we see it globally also, it is estimated that by 2050, 90% of the Earth's soil could be degraded. And in India, almost 63% of the Indian soils are under severe stress with less than 0.5%, as I said, organic carbon. So we need to devise a solution that could not only secure the health of the environment, but also secure the health of the animals, plants, and human health. So that's why the concept of One Health comes into concentration. But if you could see, the soil is at the central point of this One Health, because If our soils are healthy, then only our plants and animals could be healthy, and then the human beings would be healthy, and the environment would be healthy. So we need to focus on the soil health. Next. So the other problem that we have in hand is it is estimated that the population, globally is going to increase by 10 billion by 2050, and in India the population would surge to 2 billion by 2050. So to secure the livelihood and the for the food security, we need to increase our food production by 2 times. We need to double it. But by then time, if we do the same kind of a farming, our percentage of the corresponding farming methods would be less than 4%. Sustainability would be less than 4% if we continue to do the agriculture the way we are currently doing. And almost only 2% would be organic in India. So to cater the demand of humans by 2050, we need to have a system in place that could be sustainable. And one of the solutions in bringing the sustainability in agriculture is vermicompost. But there are various issues, like how can we increase the organic inputs in the soil or in the agriculture for the agricultural use. So for that matter, we need to have the capacity where we can cater the demand of the organic inputs in agriculture, especially in India. And organic manure or vermicompost is one of the sustainable solution. Next. Next, please. So what is vermicomposting? Vermicomposting is an nutrient-rich natural fertilizer which is produced by the process of vermicomposting. So in vermicomposting, we are utilizing the earthworms to decompose the organic waste. It is essentially the worm casting, the excrement of the earthworms that are rich in humus and beneficial microorganisms. This process transforms the various organic materials like food scraps, wastes, and agricultural residues into available soil amendment that improves the soil structure, aeration, nutrient availability for the plants. Next. Next, please. And how it is done? Worms are placed in a bedding under controlled climate to thrive. They feed the common agricultural and biodegradable byproducts like cow dung, crop residues, kitchen waste, etc. They break down the scraps into their original components and produce nutrient-rich humus. This composted material can then be used to improve and enrich our soils. Next. Go to the next slide. There are various benefits of vermicomposting, like it improves the soil biology, physical and the chemical properties of the soil. It increases the soil water retention capacity. The resinous substance excreted by the earthworms help in increasing the water retention capacity of the soil. And it also helps us in increasing the soil aeration. Different species of earthworms have been found to make extensive burrows, which can make soil loose and porous, and thereby they improve the water retention, aeration, drainage, and also enhances the root proliferation. And it also helps us in reducing the soil erosion because the resinous substance excreted by the earthworms is polysaccharide gums produced by the earthworms in earthworms' intestinal bacteria. These substances are occluded with the soil, which forms water-stable soil aggregates. Now, it also helps us in evaporation, in reducing the evaporation rate. The peritropic membrane release from the intestines of the earthworm solidifies and forms a transparent film over the vermicast, and thereby reducing the rate of evaporation. And it also helps us in the stimulation of the microbes. The microbial load of the ejected material from the earthworm body is more because of the congenial environment for microbes inside their body. The ejected material also contains various enzymes like amylase, lipase, cellulose, protein, and chitinase extra, which continue to disintegrate the organic matter. Next. So all in, I can say vermicompost serves as a plant growth regulator and a biocontrol agent. Besides enhancing the physical, biochemical fertility properties of the soil, and while suppressing the pest attacks, it is enriched with the auxins, gibberellins, gibberellic acid, cytokinin, humic acids, which improve the plant adaptation to abiotic stress. Uh, Vermicompost, this is one example, as we know that in clay soils, the water holding capacity is highest in clay soils, while it is less in loam soils, while in sandy soils, there is lowest water holding capacity. That's why the highest runoff is in the sandy soils. And it has been seen that when we add the vermicompost, uh, it reduces the water evaporation by 30%. If you go to next slide, go to next slide. Please go to next slide. Next slide, please. Yeah, the study has been conducted by LAN, in which they found that vermicompost is effective at increasing the water holding capacity of the sandy and loam soils by up to 30%. Next slide. Now, it also helps us in disease suppression by four main methods, like by competition, antibiosis, hyperparasitism, and induces systemic resistance. Through competition, it reduces the availability of the resources such as space, nutrients, energy, or carbon to pathogens. And by way of antibiosis, it produces specific metabolites and antibiotics by interacting with the pathogens. And by way of hyperparasitism, the microorganisms colonize the pathogens, which leads to their death. And it also induces systemic resistance mechanism in plants that is activated by the infection, like anthracnose in pepper and cucumber, mediated by the compost extract using induced systemic resistance. Next. This is one example in germinants of cucurbitaceae. The zoospores, during the emergence of the seed, they find the rhizosphere quite congenial, which is, they find the chemicals. Go back to previous slide, please. Previous slide, please. Previous slide. Previous slide, please. Go back to previous slide. Yes. So by way of chemical, communication, these zoospores attack the rhizosphere or in the rhizospheric atmosphere of the germinating seed. But in case of vermicompost, it alters the chemical composition of the rhizosphere, and the zoospores find it difficult to attack or reach to the germinating seed, and thereby it helps us in pathogen suppression. Next. Vermi technology basically involves three main steps, which are interlinked and interdependent processes. One is vermicomposting itself, another is vermiwash, and third one is vermiculture or vermery. Next. Before I could speak about those, let us know about the earthworms. Earthworms are the most important macro animals in the soils, and there are around more than 4,000 species. And the size of the earthworms range from 20 millimeter to 1 meter. In fact, in some areas like Australia, earthworms can be 4 to 7 meters long. They eat dead material like organic matter or the microorganisms found on these materials. Since they eat the dead materials, they don't eat the living plants, so they do not act as pests or pests to crops. Next, and this earthworm, previous slide. And these earthworms are hermaphrodites, which means they have both male and female sex organs, but they do require another earthworm to mate. The white band, clitellum, that surrounds a mature breeding earthworm secretes mucus, albumin after mating, which later becomes a cocoon containing fertilized eggs from where the new earthworms emerge. Next. And when we see the classification of the earthworms, we divide earthworms into three main classes based on the eating and burrowing characteristics, like epigeek, endogeek, and anisic. Next. These epigeek, they are known as surface dwellers because they live above the soil level. They do not build burrows, or they are weak burrowers. Instead, they survive on eating soil litter, decaying plant material, leaf litter, and dung. They have a strong muscles for their size, which enables them to move faster other than other types of earthworms. And these earthworms are quite small in size. They have dark coloring that enables them to live above the ground surface safely. And they also have a camouflaging themselves in leaves or topsoil. And because of their dark pigmentation, they also help. It also helps them from the UV rays. Next. Next slide. Next slide, please. Next slide, please.
I have already changed the fourth slide. It is type of earthworm third and sick.
Oh, no, then there is some issue. I still have the same slide.
Participants,
Can you,
can you please confirm
can,
which slide you see? Participants, please unmute and confirm.
seems like I am at the type of earthworm, one epigeek.
No, I'm on third. That's why I interrupted.
I think it is a
Hello,
network issue.
participants. Which slide you see?
Ma'am, type of
Participants, can you please confirm?
yeah, ma'am. Type of earthworm.
Epigeek.
Type of
Epigeek.
earthworm, part 1, 2, or 3?
G
Anything?
one. Yes, ma'am.
1?
Type of earthworm on the earth.
Yes.
Epigeek.
Yes,
G.
yes. It's epigeek. Why not? I had already changed the slide. Endogeek.
Reshare. No, please reshare your presentation.
Okay.
Can you see my presentation now?
Yes, sir.
Okay, fine. Now, is it okay now?
Yes, sir.
Very good. So let me get to the slide. So yeah, we were here. So these epigetic earthworms, they have a very rapid composting process. They rapidly consume the raw materials and excrete the composting materials, and they are able to reproduce very quickly also. And one of the best examples is the Eisenia fetida. Then there is second example, which is endozoic. Endozoic means within the earth. They are most commonly found in the uppermost layers of the soil, where they create semi-permanent horizontal burrows or under rocks or logs. Through some will burrow deep into the soil, though some burrow little deep into the soil. They are typically they make appearance typically on the ground surface in instances of heavy rain, as extra moisture prevents them from drying out. These endozoic earthworms are totally borrowing and eat organic stuff down beneath the soil surface. These earthworms have a pale look and they lack pigmentation. So, in order to avoid the UV rays, they normally remain deep into the soils. Then we have third type of earthworm, which is anasic, which means out of earth. These earthworms live below ground and they come up to soil level for their food. The head portion is red or brown, and the tail is light color in comparison to the head portion. These worms are those that burrow vertically in the mineral layer of the soil, which thereby creating a permanent vertical burrows as deep as 6 feet below the below the surface level. These burrow systems are quite extensive and can be as big as 1 inch in diameter. And these earthworms are also used for the fishing bait. They have a very weak muscles and are the slowest moving of all the types of the worms. And they do not have any need to move quickly. They have more pigmentation, but are often a milky color, especially native worms as they predominantly reside underground. And some of the examples are here. Among them, Lambricus frendi is the popular, most in appearance. And these are some common names and the scientific names of these earthworms, like Lambricus rubelis. These are known as by red-headed earthworm or red earthworm. Then we have Allolobopora chloritica, which is known as green worm. Then Eisenia fetida, branding worm. Then Aprorectodia longa, which is a black-headed worm. And these are some comparison between these three worms, which I have explained. Now, if we talk about the Eisenia fetida, this is the most common species, known as regular or red worm, or the tiger worm, or the maneuver worm. They eat at least half their body weight per day, and about 1.5 kg worms comes to around 1,000 red worms. The mature worm can produce 100 worms in a year, and they live up to 1 year. They breathe through their skin, so it is important to keep them or their environment moist. Otherwise, also if we keep the surface too wet, they die. They also release coelomic fluid, which acts as a defense mechanism against the predators. As it smells bad, the bad smell is thought to be the basis of their name, fetida, which in Latin term means foul-smelling species. Red earthworm is preferred because of its high multiplication rate, and thereby it converts the organic matter into vermicompost within 60 to 80 days. Since it is a surface feeder, it converts the organic material into vermicompost from top. A mature red wrinkle, which is around 2 to 3 months old, can produce 2 to 3 cocoons per week, and each cocoon averages 3 hatchlings. Cocoon takes up to 11 weeks to mature and hatch. Then these hatchlings require at least 2 to 3 months before they grow to be mature for breeding worms. Therefore, the population productivity over 11 weeks, if we estimate, one worm multiplied by 3 cocoons per week and multiplied by 3 hatchlings per cocoon comes up to 9 hatchlings per week. And that amounts to 99 for 11 weeks. So in 2 to 3 months, those hatchlings will be matures as breeders, and they'll be producing offsprings of their own. So at the same time, their parents are continuing to mate and create offsprings. The materials, suitable and non-suitable for vermicompostings are suitable are like crop and animal residues, vegetable waste, hotel refuse, weed biomass, leaf litter, waste from agro industries, biodegradable portions of the urban and rural wastes. And the things that are not suitable is like meat, greasy or oily foods, plastic like polythene, oil or any other organics, non-organics, bones and dairy products, cat or dog feces, materials with pungent substances like onion, garlic, and chili. These are not suitable. Then citrus and lemon peels. The ideal parameters for vermicomposting include the temperature has to be around 25 to 35 degrees centigrade, which is ideal. And they also like on the partially decomposed food. So therefore, 30 to 45 days old cow dung is, the ideal vermicomposting fooding material for the earthworms. And they also love to be at a soil moisture level of around 60 to 70%. Aeration has to be there because this is an aerobic process. And then the ideal pH is around 7. Then there are various methods of vermicomposting. You might have also seen like heap methods are there, pit method is there, and then low-cost vermicomposting method, which is modification of a pit method. And we have portable vermi beds, and then we have vermicomposting prepared above ground by using the cement rings. These are some of the methods. You can see them pictorially. Vermicomposting in pit methods, it is preferable to go for optimized sizes when we go for the pit method. The optimum size being 20 feet in length, 3 feet width, and 2 feet deep. And series of such beds can be created at one place. Then vermicomposting by ground heaps. In this, dome-shaped beds or heaps with organic wastes are prepared on ground, and the optimum size being 10 feet in length, 3 feet width, and 2 feet height. Now, whenever we prepare this pit vermicomposting, the underground open permanent pits of size, say like 3 into 2 into 2 feet, this has to be constructed under the shade in order to avoid entry of rainwater into the pits. The floor of the pit should be partially concrete with some small stones and pieces of the bricks. Above ground brick walls should be constructed above the pit floor with the dimensions of 10 into 3 into 3 feet. And then partially decomposed dung, which is about 30 to 45 days old, should be spread on bottom of the pits to a thickness of 5 centimeter. And this should be followed by the addition of the layer of the crop residues or the dung in the ratio of 1:1. The second layer of the dung should then be applied, followed by another layer of crop residues in the same ratio up to a height of 2 feet. Now, there are 2 species. One is epigetic earthworms. They are being used at the rate of 1 kg per quintal, like Eschenia fotida, under temperate conditions of Kashmir. Then we have Pyrionex excavatus under tropical conditions. The moisture content should be maintained at 60 to 70%, as I said, throughout the decomposition process. We can use jute bags or gunny bags spread uniformly on the surface of the material. It will facilitate the maintenance of the suitable moisture regime and the temperature conditions. Watering by sprinkler is preferred most often. Water should be sprinkled every third day to maintain the adequate moisture, depends upon the climatic conditions existing at that point of time. The material should also be allowed to decompose for 75 to 100 days. The forestry later is takes more time, around 75 to 85 days, than the farm residues. Farm residues take more time. So this method is not preferred due to poor aeration, waterlogging at the bottom, and because of more cost of production. Then we have a heap method. In heap method, the waste materials are partially decomposed in 1:1 form. These are made in dimensions of 10 feet, 3 feet, and 2 feet. The inoculation channels are made by hand, and earthworms at the rate of 1 kg per quintal of waste are inoculated. Then watering is done by sprinkler method, as usual. Then jute cloth pieces or grasses are used as a covering material. Other protocols are followed as in pit method. So like here I have shown in the examples. First we go for the pit filling, then addition of the earthworms, Eisenia fetida. As I said, these are surface feeders. And then we keep on sprinkling the water to keep the moisture level at 60 to 70%. Then turning off a vermicomposter to increase the aeration. As I said, it is an aerobic process. And then when the compost is ready, we go for the sieving of the compost. Then there is one more method, which is portable vermibed. These are often, very popular when it comes to small scale vermicomposting. These portable beds have dimensions of 12 into 4 into 2 feet. And again, they are kept under shade to avoid the rainwater into the beds. And the rest of the preparations are more often same. So these you can see these examples. Then we also use cement rings. These waste materials is prepared on a polythene sheet placed on the ground. The heap of around 1 meter, which is 3 feet in height, is spread in layers. The top of the heap is plastered with the soil or cow dung. Then the material is allowed to decompose 30 to 40 days. The earthworms are released 1 kg per quintal through the cracks developed. The heap is covered with the straw or the gunny bags to prevent the moisture loss and the birds from picking the earthworms. Then, of course, water is sprinkled to maintain the adequate moisture and body temperature of the earthworms. The size of these cement rings should be around 90 centimeter in diameter and 30 centimeter in height. And organic dry waste is around 50 kg can be added. Dung slurry of 15 kg, then rock phosphate if we want to fortify this vermicompost. Then earthworms at the rate of 500 to 700 numbers. Then water of 5 liters every 3 days is used. The various ingredients are used in the ratio of 5:1:5, 0.2 is to 50 to 75 is to 0.5. And these are some examples of cement rings. Then the harvesting of the earthworms. The one way involves the moving the finished compost and the worms over one side of the bin, and then adding new bedding material and food waste on the other side. The compost can be placed in small pieces on a trap in the sun, and because worms don't like light, they will wiggle to the bottom of the piles. Small and fresh cow dung ball is made and inserted into the bed in 5 or 6 places. And after 24 hours, the cow dung ball is removed and all the worms will be adhered to the ball. So these are 3 main methods of harvesting the earthworms. Then we can also go for the biofortification of the vermicompost, like with the beneficial microorganisms like azotobacter, phosphate, solubilizing microbes, rhizobium species, trichoderma, or the BAM. Then the other process is about the vermiculture, which is the multiplication of the earthworms. The earthworms can be multiplied in 1:1 mixture of cow dung and decaying leaves, which can be kept in a cement tank or a wooden box for the matter. And the nucleus culture of the worms needs to be introduced into the above mixture at the rate of 100 worms per 10 kg of the organic waste, and the unit is to be kept in shade. The chemical composition of the vermicompost depends upon basically the feed, and normally you would see the content of the NPK and other micronutrients would vary from material to material, but on an average, the nitrogen content of the vermicompost is around 1.14, the phosphorus is near about 1%, and the potassium of around 0.72. Then when it comes to rate of application, the dose of vermicompost application depends upon the type of the crop grown in the field or nursery. In general, for in case of field crops, the recommended dose of application is 5 to 6 tons per hectare, while in case of fruits, it's around 5 to 7 kg per plant. And if we use them in the pots, the rate is around 100 to 200 grams per pot. And when we talk about the economic benefit, there's a huge economic benefit. If we do go for the vermicomposting at a small scale, the cost benefit ratio is around 1:1.73. At a medium scale, the cost benefit ratio is 1:1.85. And when we talk about the large scale, it can go as high as 2%, 1:2. Then there is another byproduct of the vermicomposting, which is vermiwash. And vermiwash is basically a liquid fertilizer, which can be collected through the column of the activated earthworms. So it contains plant growth hormones like auxins, cytokines, apart from nitrogen, phosphorus, potassium, and other micronutrients. So here you can see we use buckets with a tape. So normally this bucket has a 10 to 15, it is filled with 10 to 15 centimeter of gravel at the bottom, and then we add 10 to 15 centimeter of sand, and above that we place 40 to 45 centimeter pre-decomposed organic wastes. The earthworms decompose and release these, So yes, over this layer, we put another layer of sand, which is around 10 to 15 centimeter. Then we put a layer of partially decomposed cow dung, and above that we put 1,000 to 2,000 numbers of earthworms in the bucket. After that, a layer of paddy straw having 6 centimeter thickness is given. We hang one pot with the bottom hole over the bucket in such a way that so that the water falls drop by drop. And then we stop cork the bucket and spray water regularly for a period of 7 to 8 days. After 10 days, the liquid vermin wash will be produced in the bucket. So this is one example. The composition of vermin wash, again, it varies depending upon the food ingredients that we use. But normally the organic carbon of the vermin wash is around 0.08%, and nitrogen is around 0.1%. It also is rich in micronutrients. Now, vermicomposting is ideally suitable for a small to large scale. And, it helps us in the personal recycling, and composting can be managed in limited space as well. Commercial vermicomposting can be operated outdoors with large volume of waste. In such cases, controls are made for odor, moisture, and temperature pests. But if you see in India, the situation right now, India generates about 350 million tons of agriculture waste and 42 million tons of municipal waste annually. And the time taken by the conventional methods that I have been talking is too much. They take around 4 to 5 months. And the operation is also labor intensive. We normally use manual things, which involves high cost, and there is low profitability. And it also limits to the low production. Quality-wise, if we see, the quality of the vermicompost is often not up to the standard. And there is no control on the nutrient composition, as I said. The execution is also very difficult because it requires huge quantity, and thus challenges the implementation of the organic farming, which I was first talking about, why India should go for organic farming and why sustainability is required. So there has to be a technology that can help us in real-time monitoring and production of controlled environment, resulting in diminished production, efficiency, and quality. So we at our institute have developed a dynamic IoT-driven nutrient-enriched vermicomposting unit. It is a patented technology. We have used the, developed the machine, IoT-driven, and it has the potential to go for the industrial setup or the production of the vermicompost at the industrial level. So it's IoT driven. So there is input control, there is operational efficiency, and execution. In execution, it is highly automated. It increases the production, the quality wise, the quality of the vermicompost is high, and it's time effective also. It takes less time in the vermicomposting. So we have named it as a vermitonic, which is a premium organic fertilizer meticulously crafted by nature's recyclers like earthworms. And we can fortify it with the additional organic nutrients, minerals, trace elements, or the microorganisms like azotobacter and other phosphorus solubilizing microorganisms. And thereby, it can help us in producing the plant with a balanced diet for optimal growth and flowering and fruiting. So if you want to know more about this, you can search. There is a website, farmhealth.in. You can visit there and you can get more information about this product. So I conclude here. Let's turn this organic waste into a valuable fertilizer called black gold through vermicomposting. So if you have any questions, I can take your questions right now.
Thank you, sir, for your nice presentation.
Thank you.
Hello, any participant who wants to interact with Dr. Shabir Ahmed?
Dr. Saab, could you put light on the temperature and suitable temperature and kind of requirement for the earthworms?
The best, yeah, please.
Sometimes we face the difficulties because we are considering, we are suggesting to farmers that this is the temperature and you will get all the things, but many times it will not happen.
Yes. So as I said, the best temperature is around 13 to 27 degrees centigrade in between, it can go up to 35 degrees centigrade as well. But then to maintain it is very difficult. That's why we also developed this machine, which is IoT enabled. We use the, thermometers, we use IoT sensors, and it automatically rains whenever the temperature goes high. It automatically, sprinkles the water within that machine, and it lowers the temperature. And the sprinkler irrigation through sprinkler stops whenever the optimum moisture is reached, which I said is around 60 to 70%. So yes, of course, there is a difficulty in maintaining the temperature and the moisture level. That's why we need to embrace the technology nowadays, which is available at our hands, like using various kinds of sensors, maybe soil moisture sensors or soil temperature sensors.
Sir, I am from North Gujarat, and in some of the pocket we have issue of the TDS, have very high TDS water, around 4,500 kind of the waters from the site. Every time this canal water is not available. We have canal water. Sometimes we are making this water pond also in the field, but this is one of the very big constraints because that earthworm not survive. What extent we can advise farmer that this much TDS is okay for the earthworms?
So for that, what I would suggest is to use the water tank. So you will have the 24/7 water availability. And to reduce the human labor into that, just put the water pipes over the top of these pits, and have kind of a system where you can sprinkle the water would directly from come down from these water pipes onto the pits. So that way you will also avoid much of the labor. But the best thing is to have water tanks on board, so as to have the availability of water 24/7. So that could be the only solution.
Sir, my concern about the EC of the water, because in our pockets we have TDS of the water is around 4,500. My concern, what extent it will survive and efficiently work?
Normally the EC has to be less than 1, but if it's like more than 1, then it is better to treat the water with various chemicals so as to reduce the electrical conductivity to less than 1. So
So
that
which
could be.
chemical you advise? Because sulfuric acid, sometimes some people are suggested, but I have, in my experience, it's not very much effective.
I think there are various commercial, I need to look into that, but I would not directly suggest to you to use any chemical. But there are some commercial chemicals that you can use. Maybe I need to look into that.
Sir, could I get your number?
Yeah, sure.
In chat box, so it will